Topology Gate 2017. Consider the topology tau equals to u subset of z such that z by z minus u is finite or 0 does not belongs to u on z. Then the topological space z comma tau compact but not connected but not compact, compact but not connected, both compact and connected, neither compact or not connected. Okay, so friends, this kind of problem is very simple. At first you have to know that z minus u equals to u complement in z. So friends, in here also they say or, okay, or 0 does not belongs to z. Okay, this is also very good. 0 does not belongs to z. Now friends, now or means, or this meaning of or equal to union. Okay, this meaning is union, means where 0 does not belongs to z. If sorry, does not belongs to z, sorry, it is not does not belongs to z, it is given that 0 does not belongs to u. Okay, this is my question that is asking. Okay, 0 does not belongs to u. Happened that u take u complement equals to minus 3 minus 1 0 3 2 0 3 4 5 up to infinity. Okay, so that complement, suppose u complement u is equal to this and u complement this. Okay, so whatever I get this value u complement equals to, u complement can be written as 1 comma 2, so that implies u belongs to tau. U belongs to tau, so u belongs to tau. Suppose u is equal to, suppose a is equal to, I can say a is equal to 3, okay, and b is equal to 4. Okay, we can write now x comma tau is disconnected if a comma b, if a comma b belongs to tau open set, open with, okay, open with a comma b does not equals to phi, then x equals to a union b. Okay, this then x is equal to a union b, and a intersection b equals to phi, then it is disconnected. Okay, then x comma tau is disconnected, connected and disconnected, connected set and disconnected set. Okay, so it is disconnected. Now friends, it is very very important and you have to remember this topic, that if a comma b belongs to tau, then it is disconnected. Now a comma b belongs to tau and a equals to 3 belongs to tau open. A comma b belongs to tau and a equals to 3 belongs to tau open. So b equals to, b can be written, okay, in here I have written down b is equal to not 4. Okay, in this case. Okay, now I just remove this, I write in here. Okay, clear way. So b can be written, b to -2, -1, 0, 1, 2, 4, 5, 6 up to this. Okay, b can be written this way. So b complement equals to 3. So comma b a, okay, a, it does not equals to phi, and a intersection b equals to phi. So a union b equals to 3 intersection -2 -1 0 up to this. Okay, that equals to capital Z. Okay, we can say it is capital Z. So Z comma tau is disconnected, okay. Now friends, you see that it is Z comma tau is equal to disconnected. So Z minus u is equal to finite. So then the topological space Z comma tau is connected by both compacted connected. This is not possible. Connected is not possible. So now I have to choose a comma d. It can be possible. A will go to discuss that every open has finite subcover. Okay, what is the meaning of the compact space? Every open cover has finite subcover. Okay, every open cover has a finite subcover. So now v lambda belongs to capital lambda, belongs to tau, topological tau open set. Okay, we can say every open cover has a finite subcover. Okay, union of lambda belongs to capital lambda. Okay, so friends, you see a equals to 3t and b equals to -3, -2, -1, 0, 1, 2, 4, etc. Okay, 4, 5, etc. So only 3 is not present in here, equals to Z. So it is finite finite subcover. You see, according to the definition of the compact space. Okay, this is the definition of, this is my definition of compact set. So I hope it is clear. Thanks for watching.